Hello everyone, I am Ketan Kale and welcome to a brief introduction to Oozie. So in this presentation, we are going to look what Oozie is, how it is used in the Hadoop ecosystem, what are its key features, and what are its key components. So let us start. Oozie is a workflow scheduler system to manage Apache Hadoop jobs. So as we all know, that in big data there are a huge number of jobs that need to be performed parallelly. So in doing so, we need a dedicated scheduler system which would decide a particular workflow for so that the jobs can be run smoothly. Now Oozie is one such service, which is a workflow scheduler system, and that manages these jobs. Oozie is integrated with the rest of the Hadoop stack, supporting several types of Hadoop jobs such as MapReduce, streaming MapReduce, Pig, Hive, and Scoop. So Oozie can be easily integrated with the other Hadoop with the rest of the Hadoop stack, that is the rest of the components in the Hadoop ecosystem, and it supports several kinds of jobs such as the Java MapReduce jobs, streaming MapReduce jobs, Pig, Hive, and Scoop jobs. Oozie is a scalable, reliable, and extensible system. So these three features are the ones that make Oozie stand out and make it a popular choice among the customers. Oozie is used in production at Yahoo, running more than 200,000 jobs every day. So this shows us the capacity at which Oozie can work. It can process up to 200,000 jobs every day. Now, in order to understand how Oozie works, we need to understand a few basic terms. So let us start with them one by one. So first, let us understand what a workflow is. Oozie workflow is a collection of actions arranged in a control dependency DAG, that is a direct acyclic graph, specifying a sequence of actions execution. This graph is specified in HPDL, an XML process definition language. So basically, a workflow is nothing but a flow of jobs and a collection of actions, and the sequence of the actions execution. So a workflow defines the actions that are to be performed and the sequence in which they are to be performed. A workflow definition is a DAG with control flow nodes and action nodes, where the nodes are connected by transition arrows. Now what these control flow nodes and action nodes are, we will see in the subsequent slides, in the further slides. Now there are a few components that Oozie has that we need to understand so that we'll understand the working of it. One of them is the property files. Now Oozie workflows can be parameterized. For example, in a workflow, say at one stage we need to specify a parameter that would be used as an input for the other stage. We can do so using the property files. The parameters come from a configuration file called as property files. We can run multiple jobs using same workflow using multiple .property files, so that we can specify only one workflow for multiple jobs by giving different parameters to it using the .property files. Now say for example, in a code we need to replace one particular term with a particular parameter. Then what we do is we use the $name node variable, so that whenever that particular part is executed, that that place $name node is replaced with the parameter from the .properties file. Then the next component that we are going to learn is the coordinators. Coordinator applications allow users to schedule complex workflows, including workflows that are scheduled regularly. Oozie coordinator models the workflow execution triggers in the form of time, data, and event predicates. The workflow job mentioned inside the coordinator is started only after the given conditions are satisfied. So basically what a coordinator does is that it makes sure that certain particular conditions are satisfied, and it triggers the execution of the workflow. Now these triggers can be in the form of time, data, and event predicates. For example, if a particular event, if we need to specify some execution only after a particular event, then we can employ a coordinator for that purpose, and we can ensure that a particular event is uh, when a particular event occurs, only then a particular execution should take place. Then we can use a coordinator for that purpose. The third component that we'll learn is bundles. The UZI bundle system allows the users to define and execute a bunch of coordinator applications, often called a data pipeline. There is no explicit dependency among the coordinator applications in a bundle. However, a user could use the data dependency of coordinator applications to create an implicit data application pipeline. So basically what happens is, whenever we say group together a bunch of coordinator applications, we form a data pipeline. Now there's no dependency among these coordinator applications in a bundle. But when we use data depend but we can use the data dependency of the coordinator to employ a particular dependency when we in that data application pipeline, so that so that we create an implicit data application pipeline. Now as we had seen earlier, there are two types of nodes in a control flow, in a workflow actually. The first type is the control flow nodes, and the second type is the action nodes. So let us see what a control flow node is. Control nodes define the flow of execution and include beginning and end of a workflow and mechanisms to control the workflow execution path. So as the name suggests, in a workflow, these are the nodes that govern the control flow, the control of the system. So the control flow provides a way to control the workflow execution path. Flow control operations within the workflow applications can be done through the following nodes: start, end or kill, decision, fork or join. So these are the types of the nodes that come under the control flow nodes. We will see an example. We will have a clearer idea of this when we see an example. Then the next type of node is the action nodes. Action nodes are the mechanism by which a workflow triggers a particular execution of a computation or processing task. UZI provides support for the following types of actions: MapReduce, PIG, HDFS, sub workflow, Java. So these are the different types of jobs that can be performed, that can be specified in a workflow. So this is a sample workflow where we can see that there are different control flow nodes and action nodes used. To start with, the first node that we encounter is the start node, which is a control flow node. Then comes the hive job, which is an action node. And whenever the start node gives its inputs to the hive job is executed. Then this hive job gives the output, gives its output to the fork control flow node, which is again a control flow node, and it forks that job into two jobs: shell job and pick job. Now these two jobs execute on their own independently, and then combine their outputs in the join node, which is again a control flow node, and then it is given to the decision node. And according to the decision that is made, either of the branches of the control flow are executed. Either the hive job is executed or the shell job is executed. So this is how the control flow is made, and this is how it works. Now let us look at some key features of UZI. Now UZI server provides a REST API support where each request is being authenticated by pluggable authentication module. So there's a particular module that authenticates each and every request that the UZI server gets. Now the workflow engine accomplishes these through a set of predefined internal subtasks called commands. So there are specific different types of commands that are used to implement the UZI job. Now most of the commands are stored in the internal priority queue, from where a pool of worker threads picks up and executes those commands. So all these commands are stored in the internal priority queue, and whenever the turn comes, each of the commands are performed by a pool of worker threads which execute those commands. So this is a diagrammatic representation of the web service that Oozie provides. So to start with, the first layer that we encounter is the security layer. Then the web services API and WS callback, that is a web service callback layer we are used, which provide an interface between the user and the workflow engine. These web services are nothing but the JSON or REST API. Now the next layer that we encounter is the workflow engine. Now the workflow engine, what it does is it controls the whole set of commands, the command queue, and the command executor thread pool. So now in this diagram we can see that this diagram is color coded. So all those blocks that we are seeing in green color are memory resident. That is, they are resident in the memory of the system. Whereas all those blocks that we see in the purple color are executed asynchronously. So the commands like create action, start action, check action, all of them are executed asynchronously. Then there are layers like secured Hadoop accessor, which is an authorized module that accesses the Hadoop, and then there is a persistence store, which connects to the SQL database. So let's continue with the features of Oozie. Oozie has built-in auto recovery mechanism where a dedicated thread periodically runs to monitor the progress of all the active jobs and takes necessary action if a job is stuck in some states. There are two daemon threads, one for purging the old records from database and the one to check the external status of any submitted Hadoop job. Oozie supports multiple databases such as Oracle, MySQL, Apache Derby, etc. to store the internal states through a generic persistence layer. As we saw in the diagram earlier, there's a persistent layer that connects to the SQL database. So this SQL database can be anything. It can be an Oracle database, MySQL database, Apache Derby database, or etc. Oozie quickly returns the worker thread back to the thread pool and later checks for job completion in a separate interaction using a different thread. So in this way it ensures high performance, and it ensures that no thread is being used for a long time. Now thus far we have seen a theoretical working of the Oozie system. Now let us go through some commands quickly so that we can understand what these commands do. Now Oozie job options. So if we specify the action option, we can we need to give the action ID as the argument to this command, so that a particular action can be performed on a particular coordinator. Then there are commands like the config command, which accesses the .xml or .properties file of a particular job and then can be edited using this command. Then there's a command called do as command. So the do as user, what it does is it impersonates a specified user. So for example, we need to perform a particular command as a particular user, then we can use this command to do so. Then there's a command called info to get the info of a job. Then we can kill a job using the kill command. Then there's Oozie command, which specifies the particular URL that we are going to use for Oozie. And then there are some commands that we use for manipulation of jobs, such as rerun, which reruns a job. Then there's a command called resume, which resumes a job. Then there's a command called run, that runs a job. Start a job. Then submit can submit a job, and suspend can suspend a job. So that's it from the presentation. Thank you so much.